All right, welcome back. I hope you guys got some nice drawings down on your notes there, and if you didn't already, I encourage you to share some of your ideas with your classmates after we're done today. This is an interior image of the World Trade Center towers that shows the effect of that very dense network of columns required by the punched tube concept on the interior spaces. If you're not looking straight out the windows, you almost couldn't see out of the building. In contrast, this is one of the really stunning spaces where the X-braces of the Hancock building come together with one of the verticals. All right, the next part of our discussion of the modern skyscraper in New York has to do with green skyscrapers. This is the Condé Nast building near Times Square, with many green features as part of it, having to do with energy efficiency, not particularly having to do with structural efficiency. Later on in the Green Buildings lecture, you'll have some discussion of how structural design and energy efficiency can actually intersect with one another. But this was a building that appeared at the beginning of the green skyscraper movement, certainly at a new scale for green skyscrapers in New York, and is significant for that reason. The New York Times has a new headquarters building, which also has some green and sustainable concepts implemented in it, including this sort of scrim here, which is intended to not just be aesthetic, but is actually intended also to provide some partial shading to the interior spaces and reduce air conditioning costs in the summer. Some at the New York Times building, some interesting structural details also expressed here externally to the building. Modern towers. The Hearst building. The architect Norman Foster and the engineer Cantor Seynuk. A really interesting structure for a few different reasons that we'll look at here. Nice glass and steel tower with a peculiar base. And the story is that the base of the tower was built many decades ago, and the plan had been to, just as with the Singer building, erect a tower clad in masonry out of it. But that part was never executed. So you were left with this low-rise building in prime real estate on 57th Street in Manhattan without much height to it. And so in the 2000s, I think it was, maybe the late 90s, I should know that, they decided to actually build the tower. The foundation and the supporting structure was already here, but they went with a modern design, largely credited to the architect Norman Foster. And I want you to look carefully at this design and try to describe the load path for gravity forces in this structure. And I want you to comment on the advantages and disadvantages of that possible load path. And I'm going to give you about 30 seconds to do that. Okay, good. I hope what you noticed is that there are no vertical columns anywhere in the Hearst building. It's what's called a diagrid, and it uses this triangulated form that results in this very interesting corner treatment to carry loads down. The load path is not direct, meaning that there are no direct verticals, but it's highly redundant, which means that a load acting at this node, for example, has multiple paths to get down to the foundation. So it has a lot of redundancy built into it, which is thought to be somewhat advantageous. Singer on the left, Hearst on the right, same form, except at the Hearst building, of course, the tower is built many decades after the base. The World Trade Center towers, of course, were destroyed in 2001 by the terrorist attack, and immediately after that, an architectural, political, and structural design process was undertaken that would result in the new One World Trade Center building that is now at the site in Lower Manhattan. This was an original concept by studio Daniel Libeskind for what the new World Trade Center would look like. There was a competition of sorts, and there were some, I'd say, peculiar ideas submitted for the competition. Libeskind's design, originally conceived here on the left, was supposed to be 1,776 feet tall, called the Freedom Tower. bits of symbolism that have always struck me as a little bit too uh, blatant, struck me as trying a little bit too hard and not really appropriate. And actually, the building is no longer known as the Freedom Tower, which I think was a positive development. Liebeskind's design was not built as originally conceived, and this is the evolution over to what was actually built, which winds up being a building that is credited to Skidmore, Owings, and Merrill and David Childs. And this is the structure as it stands today. It's actually quite a nice building. There's some controversy about how tall it really is. Should you count to the top here, or should you count to the top of the antenna? The Council on Tall Buildings has actually declared that you get to count the antenna here. I don't agree with that decision, and there's often a lot of controversy about how the height of buildings are measured. There's a bit of a social story here as well. This is the lower levels of the building, and the lower about 10 stories are heavily hardened and essentially armored against further terrorist attack. It affects the aesthetics of the building, it affects the structural performance of the building, and it is, for better or worse, a reflection of the state that we find our society in today, that a significant building such as this needs to essentially be armored and windowless at the ground level. We talked about the rise of the skyscraper in New York as being driven by corporate wealth and interests, and some new proposals for tall buildings in New York are actually driven not by corporate wealth and interests, but by personal wealth and interests. This is a proposal by Santiago Calatrava for a very tall residential building in Lower Manhattan, where each one of these pods would actually be a townhouse in the sky. This wasn't built because of the financial crisis of 2008 and onwards, but there has been a renewed interest in super tall, super luxury buildings in New York. Now, Calatrava is a very interesting character. He talks about the form here, the sort of spine with these boxes hanging off of it, as being related to these kinds of sculptures and equilibrium contraptions that he's constructed over the years. But as I said, the structure was not built. Now, the final comment I'll make here is about repurposing the waterfront. And we see here a map of Lower Manhattan, and on the Brooklyn side, or a map of Lower Manhattan and Brooklyn, I should say, and on the Brooklyn side there's a former industrial site, the former Domino Sugar site here, and a developer, Two Trees developer, which has been instrumental in redeveloping the Brooklyn waterfront, not without controversy, of course, has taken on the task of redeveloping this site. This is how it looks today. Factory buildings, abandoned now, with the Williamsburg Bridge here on the left. And this is what the proposed suite of tall buildings will look like. The refinery building being repurposed, and then a series of new skyscrapers. It is relatively easy to make nice drawings of how one might repurpose an old factory building of that form. The reality is quite different. This is the interior of the building, and turning this into luxury mixed-use office and residential buildings is going to be a very serious design and construction task. Some more renderings of the structures here seen from the Williamsburg Bridge. And I want you to look carefully at these diagrammatic views of the buildings and answer this question. What do each of the new buildings have in common? And again, I'll give you 30 seconds to answer that question. Okay, they all, I guess, except for the refinery building here, they all have bridges connecting two parts of the tower. And think about what the technical challenges might be in connecting buildings at such heights. Look particularly at this one, and this one over here. And again, take 15 or 20 seconds to think and write down an answer to that question. Good. From my point of view, the main challenge is that in wind or in an earthquake, these two buildings might try to move independently from one another. The bridge is tying them together, and that creates very unusual force demands on the structure. It's not unprecedented. The Petronas Towers in Malaysia were the tallest buildings in the world for a little while and are connected by a bridge at sort of mid-height here. So it's certainly possible, but it does present some interesting structural challenges. And here are some diagrams of one of the proposed bridging schemes for the buildings at the Domino Sugar Plant. You should go to New York, you should walk across the Brooklyn Bridge, you should also ride the Staten Island Ferry, which is a nice free way to see the harbor and get a view of Lower Manhattan. These are older images that don't have the new World Trade Center building, which would be located over in this region here. So if you go, take new pictures and send them back to Professor Schaefer, and he'll make sure that I get them too. But it's worth seeing the panorama of Lower Manhattan. Trinity Church you can't really make out anymore. It's lost in the sea of skyscrapers that now forms Lower Manhattan. And of course our friend the Brooklyn Bridge still gracefully crossing the East River from Manhattan to Brooklyn and back with its partners, the Manhattan and Williamsburg bridges, farther upstream. Thanks for listening.